I'm Anil Kumar. Welcome to my series on understanding few strategies which can help us solve many types of questions. Here, based on rational expressions, I have a very important application question for you. When two resistors A and B are connected in parallel, their combined resistance R is given by the relation 1 over R equals to 1 over A plus 1 over B. Let A be decreased by 2 units and B be increased by 2 units. In that case, you have to solve these two problems. A is find an expression for the change in resistance, and B is find possible value of A and B if the change in resistance is 2 over 9. You can always pause the video, answer the question, and then look into my suggestions. So first step is, let's understand what is the original value of R. We are given 1 over R is equal to 1 over A plus 1 over B. Now the technique which I'm going to show you is also utilized for isolating variables, right? Okay, so we can take a common denominator on the right side. So we get 1 over R equals to common denominator will be A times B, and then we'll cross multiply. So you have to multiply this by B over B, right? So you get B plus A. Now we can take reciprocal of this and we can write R equals to AB over B plus A. Now B plus A is same as A plus B, so we can write R as equal to AB over A plus B, right? So that is the original value of resistance. Perfect. Now what are we doing? We are actually changing the value of A and B, and we need to figure out what happens to this value R, right? So when we say A be decreased by 2, that means we'll replace A with A minus 2, and B increased by 2 will do B plus 2, right? So we'll substitute this and find a new expression. Let's call this as R2, right? New expression, R2. So that will be, we are replacing A with A minus 2. So we get A minus 2. B with B plus 2. And the denominator, we get A minus 2 plus B plus 2. Correct? So that's a new value of the resistance. Solving, we get AB plus 2A minus 2B minus 4 in the numerator divided by, so when you open this, minus 2 plus 2 becomes 0, so we are left with A plus B. Now here, well, that is what we have as R2. So we know R2 now. What we could do is we can find the change, right? That is, let's do R2 minus R1, right? So let's do R2 minus R, the original value. So let's do part A, which is find an expression for change in resistance. So change in resistance will be R2 minus R. Now R for us is AB over A plus B, and R2 is all this, right? So let's write it down. We have AB plus 2A minus 2B minus 4 divided by A plus B. From this, let's take away AB over A plus B, right? So with common denominator of A plus B, AB minus AB is 0. So we get these three terms, which is 2A minus 2B minus 4, correct? So that becomes the change in resistance, right? So we get our expression for change in resistance, which is this. So that is our part A, right? Now let's do part B, which says find possible value of A and B if the change in resistance is 2 over 9. Okay, so I'll take this expression to the new page and then we'll solve. So what we found, here's another copy of the same question. So what we found was R2 minus R1, the change in resistance was 2A minus 2B minus 4 over A plus B, right? So I've just copied this answer, which was change in resistance, to a new page so that we can find the value of A and B. So you are saying that this change in resistance is equal to 2 over 9. So we'll equate this to 2 over 9. Now, seemingly we have only one equation, but we have two unknowns. How are we going to solve it? Well, you can actually form two different equations with these. Numerators, we have 2a minus 2b minus 4. We can equate that to 2, right? And in the denominator, we have a plus b. We could equate that to 9. So what we get here is a set of equations. So from two equations, you can always solve. Perfect. So that's how we are going to do it. So let's simplify this a bit. So we can divide everything by 2. Let's take it to the other side. So we get 2a minus 2b equals to 2 plus 4, which is 6, right? And we have a minus b equals to 6 divided by 2, which is 3. So what we have here is one equation, which is a plus b equals to 9, right? Let's write this as 1. And the other equation, which is a minus b equals to 3, right? So that's our second equation. Now using these two equations, we can actually solve for both a and b, right? So if I add them, if I add equation 1 to equation 2, in that case, what do we get? So a plus a is 2a, right? B minus b is 0, and we get 9 plus 3. So 9 plus 3, right? Okay. So we get 2a equals to 12. A equals to 12 over 2. We get the value as 6. Once we have a value for a, which we found as 6, we can substitute and find the value of b, right? Let's call this as our equation number 3. So we'll substitute 3 in, let's say 1, right? So let's substitute and then solve further. So a is 6 for us. We can write 6 plus b equals to 9, or b equals to 9 minus 6, which is 3, correct? So we get our answer, and the answer is that a is equal to 6 and b equals to 3, right? Normally, the units are ohms, which is written like this. So we can write the units, or we can say units, correct? Now in this question it is written units, so we'll say we get our answer as a equals to 6 units and b equals to 3 units. Is that clear to you, right? So that is how we can actually solve this question. I hope you find it interesting and useful. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.